Hey guys! Alright, today we're doing section 8, which is the binomial theorem. So the binomial theorem comes about from the expansions of x plus y to the nth power. So real quick, let's just go back to thinking about if you have something like x plus 2 squared. Okay, remember that you have to FOIL that. Okay, you can't just say that's x squared plus y squared or x squared plus 2 squared, whatever you have. Okay, you can't just do that. You can't just distribute the exponent through. There is a pattern that you have to follow. You have to take the first term times the first term, and the outer term times the outer term, the inner term times the inner term, and then the last term times the last term. So that's our FOIL method. Okay, so it's just not quite that easy, which is why we have the binomial theorem. It actually gives us a sort of formula to follow when we have things that we have to take cubed or to the fourth or to the fifth. You can imagine how difficult that would get if you're trying to do, x plus 2 to the fifth power. You have x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2, and it stinks. Okay, so this binomial theorem will make it a little easier. It's still not very pleasant, but it is what it is. So, first one, if I have x plus y to the 0, that's just 1, because I know anything to the 0 power is 1. If I have x plus y to the first, that's just x plus y. X plus y squared, remember you do your FOIL, so you'd have x squared plus 2xy plus y squared. Okay, if I do it to the third power, I get this. Okay, and what that leads us to is this formula here. So if I have x plus y to the n, what I can do is I can say that's the sum of my terms from 0 to n, where n choose k is my coefficient, and I have it x to the n minus k times y to the k. Okay, so n choose k, those are called the binomial coefficients, and hopefully you'll notice that my n choose k values, which are my coefficients here, I've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay, they tie right into Pascal's triangle. Okay, so you can use Pascal's triangle to look at those coefficients and find them really easily without actually having to calculate them. So if I want to find the coefficient of a to the 9th b squared in a plus b to the 11th, I can just use this formula here, and that's going to make it a lot easier. So if I'm looking for a to the 9th b squared, then let's just substitute it into this formula here. So I've got n choose k, x to the n minus k, y to the k. Well, essentially I know that if my b is y, then my k value is going to be 2. And let's just make sure that works. My n value in this case is 11. So if I do 11 minus 2, that gives me 9, a to the 9th, so that works out. So I've got a k value of 2 and n value of 11. If I want to find that coefficient, it's just going to be n choose k, so it'll be 11 choose 2. I can just plug that into my calculator, and I get 55. So 55 would be the coefficient of that term. Alright, now let's actually do a problem where I'm expanding this. And when you expand a problem like this, it's really important that you start just by expanding x plus y to the 5th. Okay, so I've got 4x plus 5y to the 5th, but I'm just going to start with x plus y to the 5th, and then I'll substitute my 4x and my 5y back in. So, if I have x plus y to the 5th, I'm going to use Pascal's triangle to think about those coefficients there. So, if I have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, okay, 1, 4, 6, 4, 1, and this will be 1, 5, 10, 10, 5, 1. So these are going to be my coefficients there. So I will have 1 x to the 5th plus 5 x to the 4th y plus 10 x to the 3rd y squared plus 10 x squared y to the 3rd plus 5 x y to the 4th plus y to the 5th. Okay, so notice that what I'm doing, I'm just using these coefficients from Pascal's triangle, and for my x values, I'm going down every time by 1, and for my y values, I'm going up every time by 1. And the sum of your exponents should always be 5 because you know you're going to the 5th power. Okay, so now that I've got this, now I can go back through and I can substitute. I know that I should have a 4x in place of my x, and I should have a 5y in place of my y. So I'm just going to go through and I'm going to substitute those values into this equation. So this is going to be 1 times 4x to the 5th plus 5 times 4x to the 4th times 5y plus 10 times 4x to the 3rd times 5y plus 10 times 4x squared times 5y to the 3rd, that was squared, plus 5 times 4x times 5y to the 4th plus 5y to the 5th. Okay, so now I can go back through and I can simplify these. So if I take 4x to the 5th, that's 4 to the 5th times x to the 5th. 4 to the 5th is just 1024, so this is 1024 x to the 5th. Okay, over here, 4 to the 4th times 5 times 5, that gives me 6,400. And then I've got x to the 4th y. Over here, 10 times 4 to the 3rd times 5 squared. Those numbers all multiplied together give me 16,000. And that's x to the 3rd y squared. Over here, I've got 10 times 4 squared times 5 cubed. All of those give me 20,000. And that's x squared y to the 3rd. Okay, over here, I've got 5 times 4 times 5 to the 4th. And that gives me 12,500. And that's x, y to the 4th. And then I've got 5 to the 5th. That gives me 3,125. Y to the 5th. So that is my expansion of 4x plus 5y to the 5th power. Alright, now let's go ahead and connect this to probability. So a coin is flipped 6 times. How many possible outcomes have at least 3 heads? Well, if my coin is flipped 6 times, basically I can relate that to the 6th row of Pascal's triangle. So if I want to figure out how many possible outcomes have at least 3 heads, well, let's just start by looking at the 6th row of Pascal's triangle. So remember, this is 0, 1, 2, 3, 4, 5, and my 6th row will be 1, 6, 15, 20, 15, 6, 1. So I'm looking at this row here. So basically what that tells me is that this could be like getting 0 heads. So if I got like tails, 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 that would be, there's one way that I could do that. This would be like getting 1 head. So I could get a head first, or I could get a head second, or third, or fourth, or fifth, or sixth. But there's only 6 ways that I could get 1 head. Okay? So I'm just going to write that out. So I'm going to say that this 1 stands for 0 heads. This 6 stands for 1 head. This 15 stands for 2 heads. This 20 stands for 3 heads. 15 stands for 4 heads. 6 stands for 5 heads. And 1 stands for 6 heads. So, does it matter that I'm looking at it in terms of heads? No, I could also be looking at it in terms of tails. This is the same as getting 0 tails, 1 tail, 2 tails, 3 tails, 4 tails, 5 tails, 6 tails. Okay, so it doesn't really matter which way you look at it, you're going to get the same thing. So I want to figure out how many possible outcomes have at least 3 heads. That means I have 3 or more heads. Well, that would be all of these. So if I add all those together, 25 plus 15 is 35, plus 6 is 41, plus 1 is 42. So there's 42 ways that I could get 3 or more heads if I flip a coin 6 times. Alright, and that is everything for section 8.